Hello everyone, welcome back again to another video from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be discussing the third video in our video series of transformation. Specifically, we're going to be discussing all the information that you need to know, everything you need to know about rotation. Now, in our previous upload, you would have already seen on the channel where we had an elaborate discussion, a very thorough discussion as it relates to translation as well as reflection. Now, reflection video was a little bit more condensed, so I had to break it up in part 1 and part 2. And of course, for rotation here, it also can be a tricky little topic in terms of the amount of information you need to know. So I'm definitely going to be breaking this video up into part 1 and also into part 2 because there's much you need to know and it can get a little tricky at times. Now, of course, link to the playlist or link to the individual video that is related to my transformation series will be pinned in the comments, or you might find it in the description, or you can actually just go on the channel, click on my playlist and search for transformation geometry. You'll find everything there that you need to know. Now, of course, primarily my contents here that I post on my page are primarily for Caribbean students that are doing mathematics yearly under the CSEC curriculum. But of course, I spread my content and my information wide and far. So of course, if you're in college or you're at a slightly higher level than CSEC, then you might also find value here in the video. Now, of course, if this is the first time here on the channel, be sure to leave a like before you go if you find any value in what you've learned today, if your objectives have been achieved. Do not forget to subscribe to the channel for daily and weekly uploads in preparation for your exams yearly. And of course, leave some positive questions and comments, and do not forget to share this out to your mathematics community and your other friends who may be in need of some assistance. All right, so without further ado, let's dive off right into the video and let's just get into rotating an object on the Cartesian coordinate system. Let's get it, guys. Let's go. So traditionally, of course, we're going to be starting off with, of course, our definition for rotation. And my definition here that I've used when I'm teaching my students is in fact that a rotation is the movement of an object onto its image by means of turning. Now, there are 3 things that you must consider when you are rotating an object, or when you're required to rotate an object. You must consider the angle through which the object is being rotated. We refer to that as the angle of rotation. You must also bear in mind where the object is being rotated from, and that is what we refer to as the core, the center of rotation. And of course, here's where the tricky bit comes in. You must be aware of the direction that you're rotating the angle through. So when it comes to the description of a rotation, well, for CSEC primarily, when they ask you to describe a rotation or describe the transformation, and we've evaluated that it is in fact a rotation, you have to describe not only the angle that it's been rotated through, but you must also make note of the point, the position from which it's rotated from, and the direction of the rotation. So those 3 things are what we're going to be discussing and talking about in part 1. Now, of course, in part 2, when I release that video, you will find that the object rotational point will change. Now, for the purpose of learning and understanding the fundamental concepts of rotation, I'm going to keep my rotational point at the origin. that is in fact 0, 0. And so everything that I discussed here is applied whether or not the rotation is at the origin or not. There's a slight subtle thing, that little change that we're going to have to learn later on. But for now, the rules that I'm going to show you here are applied specifically when the object is being rotated from the origin. Now, though there are infinitely many angles between 0 and 360 degrees that an object can be rotated through, for the purpose of understanding, we have what are known as standard angles of rotation. And these standard angles are in fact 90 degrees, 180 degrees, and 270 degrees. So it really kind of depends on if it is a standard rotation or you're just required to rotate an object through a given angle. Now, for the purpose, as I said, for the level of CSEC students, these are the three angles that we focus on. But the principle and the rules and the formulas apply when the angle is 45, when the angle is 70, when the angle is 120, when the angle is 150, so on and so forth. Now, as I mentioned earlier, that the tricky bit of this is not necessarily that the angle is rotated through 90, 180, or 270, or it's been rotated from a specific point. What makes this a little challenging is understanding the direction that you're rotating the object to. Now, for me personally, when I'm teaching my students, I particularly focus on anti-clockwise rotation. So I'm going to be showing you the anti-clockwise rotation formula, and I'm going to teach you how to manipulate the formula so as to rotate the object clockwise. There also exists a clockwise rotation formula, but I particularly just don't really talk about it that much. But we're going to be looking at everything here. Alright, now I have some diagrams here on screen that I want to kind of, give you like a preview of what is expected in this video. And so in diagram 1 here, you're looking at where I've already plotted, the image that I have here has the point A, the point B, and C plotted here. And you see my directional arrow telling you that the object ABC, which is the right angle triangle, has been rotated 90 degrees counterclockwise. That is rotating to the left. In diagram 2 here, you'll realize where the same object ABC here has been rotated to the right, that is clockwise direction, 90 degrees. And so you can see that basically the object is jumping from quadrant to quadrant, because each quadrant on the Cartesian coordinate system measures 90 degrees. So if you move from quadrant 1 to quadrant 2, that's 90. If you move from quadrant 1 to quadrant 3, that's 180. And if you move from quadrant 1 to quadrant 4, that is 270 degrees in either direction. Now, a very, very important information that you're going to need later on when I have introduced the formula for rotation, or how to derive the rotational matrix, is understanding that you can get to a particular position on the graph not just by moving in one direction, but you can alter the degree to get to that same position. What do you mean by that? What do I mean is, let's say that I'm here, ABC, and I got to this position, this pink triangle here, by moving 90 degrees counterclockwise. I could actually get to this position by moving clockwise, but I would have to change my angle. So that means then, traveling 90 degrees counterclockwise, I can get to this very same position here by moving 270 degrees clockwise. So I can go here, then here, then here. So I can get to this position by changing the angle of rotation. If I change the angle of rotation, if I change the direction of my rotation, then I have to change the angle of my rotation. Similarly over here, I got to this pink triangle by moving 90 degrees clockwise, but I could get to this position here by moving 270 degrees counterclockwise. Now, this information that I've just provided to you here is what exactly you're going to need to manipulate the formula to derive the rotation metric in a bit. All right, so let's just bear in mind, let's keep this in mind here. I'm going to get to that slide in a moment, and we're going to come back to this. We're going to be understanding more about changing the direction and changing the angle of rotation. Now, what I find, and over the years that I have learned math at the college level, from my high school, and even during teaching, I've always been taught to remember the change in the coordinates. Now, I've found over the years in my analysis of my students that students find a challenge in remembering what happens to the coordinates. Now, why this is a challenge for many students that are average or below average or even above average, sometimes they do find a challenge in remembering, is because, of course, in part 2, I had showed you guys that there is something called a reflection metric. And that metric is in fact a 2 by 2 metric consisting of ones and zeros. So upon that discussion, when you review that video, you would learn that you have a reflection metric for the x-axis, you have a reflection metric for the y-axis, you have a reflection metric for the line y equal x, you have a reflection metric for the line y equal negative x, and you're all a bunch of ones and zeros here, there. You know, many students have a challenge in remembering which one is negative, which one is positive, which one is on the top, which one is at the bottom. So that's always a challenge. And so adding to that already challenging concept of reflection metric, now adding on here 3 more metric with ones and zeros. So again, I'm going to show you how you can derive the actual metric, but I'm also going to show you a unique discovery that I made. I'm not sure how I just made this discovery, but it is quite a cheeky little way of remembering the metric. All right, but let us just first look at identifying the change that occurs after each rotation. Now you'll see here at the bottom of the screen, right here in this diagram 1, you'll see that I have a random point, right, that I'm going to rotate. So I'm going to be rotating the point xy. And so after rotating xy, if you observe the change, you'll realize that there is an interchange in the position of the point. So you notice that x here basically goes at the back, and y that was at the back is now at the front, but it has a sign change. Now in this case, you're seeing that it changes to negative, but that doesn't necessarily mean that the point is always going to change to negative. I've found students that when they see this, they think that, okay, if it's negative, it's going to remain negative. That's not the case. It basically changes sign. So if this was negative, then this would be positive. And of course, if this is positive, it's going to obviously be negative. So basically then, there is an interchange. Let me just write that down. So the ordinate, pardon me, okay, I think my space is too small, guys, so I'm just gonna verbally say it. The ordinate values are interchanged. So I switch the position of the x and the y, but upon switching, I also change the sign of the y. Now let us observe this from a numerical perspective. I'm gonna be making a comparison between point C and C prime up here. And if you notice here that point C here works out to be 4 to my right and 1 up. And then by comparing it to its image, you'll recognize that to get to C prime, you have to travel -1 up 4. And based on what we had just discussed, notice that we said that there's an interchange in the position of the points of the ordinate values, but the y changes. So notice that 4 actually went to the back and remain, but the 1 came to the front and also changed. So notice that 1 down here became -1 at the front, and 4 down here remains 4 at the back. So that is how you know that a rotation has taken place. And you're going to find also that if you check it, it is very consistent when you compare B to B prime and when you compare A to A prime. Let's double check one more point to make sure that we're on track. Here, A is 1, 2. And if you compare it to A prime, you'll find out that A prime is -2 up 1. So if you compare the points, you'll realize that the 2 that was at the back is now at the front and it changes. And the 1 that was at the front is now at the back, but it remains. That suffices here that when a rotation of 90 degrees anti-clockwise takes place, then you find here that there's an interchange in the point and the y ordinate value will change. Bear in mind that you're going to find most textbooks talking about an anti-clockwise rotation. I will use the word anti-clockwise and counterclockwise interchangeably. My colloquial language allows me to say anti-clockwise, but in textbooks you're going to see counterclockwise. All right, so that pretty much there demonstrates a little about what the change is in a 90 degrees rotation anti-clockwise. Let's have a look at 180 degrees clockwise or anti-clockwise. Now, a rotation of 180 degrees is in fact a symmetrical rotation, because whether it be clockwise or anti-clockwise, you're going to end up in the same position. And also you will find out in other textbooks or in other YouTube videos, other channels, they will also refer to a rotation of 180 degrees is basically like a reflection across the origin. So if you hear that term or you hear that sort of demonstration, do not be spooked. It's the same thing. A rotation of 180 degrees is the same thing as a reflection across the origin. Now, what you're going to find here is that if I have a point, say xy, to which I want to rotate, whether anti-clockwise or clockwise, you're going to find that there's just a change in the signs. The position of the ordinate values will remain, but the signs of the ordinate values will change. And let us just make a comparison with the points here. Let's once again compare A and say here A prime. So here you'll find that A again here is 1, 2. I went 1 to my right and I went 2 up. You're going to find also that A prime is in fact -1 to my left and -2 down. So obviously you can see that there's a clear change in the signs of the ordinate values. All right, and that's 180, and you're going to find that that's very consistent with C and C prime and B prime. All right, you can check that out on your own. And then just to hop down here for a 270 degrees anti-clockwise rotation, you're going to find here, as it says, that there's a point, random point xy that I wish to rotate. And so by rotating xy through 270 degrees counterclockwise, there is going to be an interchange in the points, but as opposed to the y changing its sign, it is the x that changes its sign. So if we make a comparison here, let us just use C and let us compare it to, let's not use C. C is too far down. My screen is a bit small. So let's just compare once again A here to A prime. Notice here that A is again in the position 1, 2. And so by comparing it to A prime here, you'll realize that A prime is in fact at 2, -1. 2, -1. So if you make the comparison, then you'll realize that there is a switch in the points, the ordinate values. So 1, 2 became 2, 1. But notice is that the x value, the 1, that changes sign to a negative here in this case. All right. So you have the choice at the moment to study the change. That means in a 90 degrees, there's going to be an interchange of the points, and the y is going to change. And in a 270 degrees, there is an interchange in the points, but the x is going to change. And at 180 degrees, the only thing that really changes is just the signs of the ordinate values. So you can actually go ahead then and study that little pattern there. And bear in mind that this is a rotation about the origin. Remember that later on in part 2, we're going to look at rotating the object from a different point. This principle of sign changes are going to remain consistent, but we have to do a slight little adjustment to how we are going to rotate the object. All right, so that's going to be quite interesting later on. Be sure to hit that subscribe button below to be notified whenever I post that video and more. Now, we're going to be discussing what is known as the rotation metric. All right, we're going to be looking at the rotation formula, and then we're going to be looking at the rotational metric formula. Now, in my previous video, you would have already seen where we discussed that there is one standard formula for reflection, for rotation, and for enlargement. And I made note of that in my previous video where we talked about the fact that the transformational metric multiplied by the object point will always produce the image location. And this transformational metric binds reflection, rotation, and enlargement. So depending on what transformation you're doing, then this transformation, this TM, can change to RM, which I refer to as reflection metric, or as you're seeing now, ROT-M, that is rotation metric. That's how I label my difference. And then you have EM later on. We're going to be talking about the enlargement metric. So this TM is going to change depending on the transformation. Now bear in mind that translation is a complete different concept from rotation, reflection, and enlargement, because with a translation it goes through a slide and glide, but with reflection it goes across a line. With rotation it goes through an angle. With enlargement it is affected by a scale factor. Now, without going off on a tangent, right, no pun intended, here we're looking at the rotation metric formula. How do I get an object to go onto its image given the rotation? Then the formula is ROT-M, that is the rotation metric, multiplied by the object, that will give you the image. And bear in mind that we have already discussed that the rotation metric as well as the reflection and enlargement metric will be a 2 by 2 metric consisting of ones and zeros. And so basically then we can use this formula down here that I have to derive the metric, because you need the rotation metric to rotate the point or the object point onto its image. Now we have two formulas here that you're seeing on screen, and that is in fact the anti-clockwise formula and the clockwise formula. You're going to find most of the time on other YouTube channels that teaches math, and in textbooks and formula sheets, you're going to find many times that this formula at the top is what they use to describe a rotation. But if you compare the two that you're seeing here on screen, you will find that there's just a subtle difference between the two formulas, nothing drastic. It's a case where if it's anti-clockwise or counterclockwise, you'll find that the top sine theta here is negative. But in a clockwise formula, all I've done here is that I've just switched the signs. Is there a personal recommendation that you're going to give in terms of which one should I do? Do I study both, or do I study one and manipulate it? I recommend studying one and manipulating it. All right. And what do you mean by manipulate the formula? Now, since we're going to say here, let us just say hypothetically that we're going to not focus too much on the rotation formula. Let us just cross this out of our mind here. And then we're going to focus only on the clockwise rotation. Let's just look at how we derive first the metric for 90, 180, and 270. Obviously, theta represents the angle. So if we want the rotation metric for a 90 degrees counterclockwise, we're going to implement 90 inside the formula here. So we're going to say cosine 90 minus sine 90, sine 90, and cosine 90. And so by plugging that in and grabbing our calculator, you're going to find that the cosine of 90 is in fact 0. The sine of 90, you're going to find that it is 1, but the negative is in front of the sine 90, so it becomes minus 1. Sine of 90 is 1, and the cosine of 90 is 0. You have that option. You can study the formula and then use the formula to derive the metric, as opposed to spending time to study where the 0 is, where the 1 is, which one is negative, which one is positive. You're going to find that you have 8 of those to remember, and it's not easy to remember all 8. You have to be in depth and be in tuned with math. So if you're just learning this for learning this case, it's going to be a little challenging to remember all of them. So I do recommend that you just kind of have the formula in your bag of tricks. All right. Now, same here. All right. Let's just make a note of that metric down here. So this is 90 degrees. So that's 0, minus 1, 1, 0. That is for a 90. Let's make a note of that. That's 90 degrees anti-clockwise rotation. Let us just remove these numbers here and remove the 90 here, and we're going to put instead 180 degrees. So that's cos of 180 minus sine of 180, and cosine of 180. And when you plug those into your calculator, you're going to find that the cos of 180 is negative 1, and the sine of 180 is in fact 0. Sine of 180 is 0, and the cosine of 180 is minus 1. So you can see that we have just derived another metric here for 180 degrees symmetrically. Okay, so it's either 180 clock or 180 anti-clock. The same metric applies here. So let's just make a note of this down at the bottom. That's 180 degrees. That's minus 1, 0, 0, minus 1. And similarly then, we can just remove these numbers here and remove the 180, and we're going to put, say here, 270. So therefore then you're going to find that the cos of 270, you're going to have the minus sine of 270, and you're going to have the sine of 270 and the cosine of 270. Plug this into your calculator. The cos of 270 is 0. The sine of 270 is in fact minus 1, but the minus goes in front of it and makes it positive 1. The sine of 270 is minus 1, and the cosine of 270 is 0. All right, and so that is how you basically derive the formula for a 270 degrees rotation anti-clockwise. Let's make a note of that at the bottom here. Now, as we were discussing earlier, that when you look at all three of these, it can be quite confusing for a student that is average, or even worse, below average. It is very difficult to remember all of these, and bear in mind that we also have 4 more, that is a reflection in the x, reflection in the y, reflection in the line y equal x, and reflection in the line y equal negative x. So it's a bit challenging. So what I do recommend is, as opposed to studying where the ones and the zeros and which one is negative and which one is positive, you simply bear in mind the formula cosine theta minus sine theta, cosine theta. Now, what we've just discussed is simply an anti-clockwise metric for rotation. But occasionally, you know you're going to get a twisted question that asks you to rotate the object, say, clockwise instead. I'm just going to show you an example. Well, I'm just going to show you all 3 examples then. Let's just erase this 270 here. All right? And thus, this is in your mind that you're only studying one formula. You only have one formula in mind here. and that is cosine, minus sine, sine, and cosine. Now, here, let us just say that you got a question that requires you to rotate the object as opposed to going 90 degrees anti-clockwise. They're then asking you to rotate it 90 degrees clockwise instead. So if they hit you with a clockwise rotation question, but you are only remembering the anti-clockwise formula, then in our slide that we had at the front here, I believe it was this one, I think it was this one, I believe, where we were discussing that if you're going to go 90 degrees anti-clockwise, it's going to be the same as 270 degrees clock, and if you're going 90 degrees clock, it's the same thing as going 270 degrees anti-clock. Now, not to fluster you a bit too much, because I know that this is a lot of information to process, I'm going to keep it at a bare minimum and discuss only one example. So here, let's say that you're asked to rotate the object, say here, 90 degrees clockwise. You cannot put a 90 degrees clockwise into an anti-clockwise formula. So if you're being asked to rotate the object 90 degrees clockwise, you're going to have to put 270 degrees into the anti-clockwise formula. Because of course, going 90 degrees clockwise will be the same position as going 270 degrees anti-clock. So at this stage here, guys, you are going to have to be the one to determine what do you prefer. Do you prefer knowing both formulas so you can use the respective formula for the respective direction rotation, or do you want to manipulate the formula? I won't press too much on that concept then. I'll perhaps have to make a separate video for just that part, but let me know in the comments, what do you prefer? Do you prefer studying both formulas, or do you prefer manipulating the formula? For now, let's keep it simple, and we can dive on into that in part 2. Alright, now as I mentioned to you before, I try to make videos to make things easier for students. And of course, I'm not sure why or how I did not recognize this cheeky little way of remembering the matrix. Let me know also in the comments if this method of remembering the matrix is easier. So bear with me, guys, and just give me some time. Again, do not forget to hit the like button and leave some positive questions and comments down below. I'm going to show you a cheeky little way that you can remember the matrix without having to remember a formula. Now, there is in fact a circle in trigonometry that allows us to remember this formula, and this circle is called the unit circle. If you're at the CSEC level, you might have heard about it. If you're at the AdMath level, CAPE level, or you're at college doing high level degrees, then you will already have known about the unit circle. And so the unit circle is a circle that is drawn through one unit above, to the left, below, and to the right of the origin. So you'll recognize that here, that this position here is 0, 1, because I went 0 units to my left and I went 1 unit up. This position here is minus 1, 0, and you will find here that this is in fact negative 1 to my left, but I didn't go up or down to get to this position. I'm already at my location. This position here is in fact 0, negative 1, because I did not go left, nor did I go right. I simply went down negative 1 to get to this position. And of course here I went I went 1 to my right, and I did not go up or down to get to this position. I'm already located here. So this is what we refer to as the unit circle. It's basically a circle that is drawn through one unit above, left, right, and below the origin. Now, with this, you can actually derive the metric for a 90 degrees, 180 degrees, and a 270 degrees rotation. You can derive the metric easily. Here is how we do it. So what we're looking at then is that I have this position here. Let's leave it here in red. And I need to get from this position here all the way to this position here. So I'm trying to get from here to there by going through an angle of 90 degrees anti-clockwise or counterclockwise. So you're going to find here that for us to derive the metric then, we're going to use the x coordinate. We're going to use the x coordinate of both points, where you're at and where you want to go, to make the first row of the metric. So the 0 here, this 0 here, and this -1 down here will make the first row of the metric. And then this last value here, this 1 here, and this 0 down here will make the second row of the rotation matrix. So 1, 0. Boom. That is your rotation matrix for 90 degrees anti-clockwise. It's pretty simple. So basically then the formula is just really using the x coordinate of the points from where you're at and where you want to go to make the first row of the first matrix. Then we use the y ordinate values of where you're at and where you want to go to make the second row of the second matrix. Let me just use some color coded here. Okay, I'm going to use color coding for the remaining. Now let's say that I wanted to move from, say, here to here. That is 180 degrees. From up here to here, that's 180 degrees, but we're going to make the comparison between this point here and this point here. So you'll notice then that this here, first x value, and this down here, 0, will make the first row of the rotation matrix. And then here you'll realize that the second number here, 0, and the second number down here, -1, basically makes the second row of the second matrix. Boom. You've just gotten the matrix for 180 degrees rotation. And then if you wanted to move, say, here in this direction, we're going to make the comparison between this and this. So you'll find out here easily then that the first number down here and the first number up here makes the first row of the 2x2 matrix for the rotation. And then the second number here and the second number up here, that's -1, 0, boom, makes the matrix for the rotation of 270 degrees. So that's a very unique way, and personally, after this discovery, I don't think I'm ever going to teach anybody the formula unless it's just a part of my requirement. But I truly find this a lot easier to remember the matrix. Now, even though for me, I remember the matrix with the formula, without the formula, or with the unit circle, you, my audience here, that are learning this for the first time, may in fact have a choice. Let me know in the comments if you prefer the formula, the individual formulas for the rotation. Do you prefer having one formula and manipulating the formula, or do you prefer the unit circle? Give it a try. Let me know how it works for you in the comments. Alright? Beautiful. So then, we are back to this. Having the rotation matrix. Now, it's easy. Once we have the rotation matrix, we're then going to use the rotation matrix to multiply the object points, and that will give us the image. Alright? And I've already written this in information here. It says that if the object is rotated 90 degrees clockwise, it is the same thing as 270 degrees clockwise. And similarly, if it's rotated 270 degrees anti-clockwise, it is the same thing as 90 degrees clockwise, and 180 degrees is symmetrical in both directions. So we've already discussed this. It's just written here in notes for you, and everything here I'm showing you how to derive the points. All right, so here I was demonstrating that if you put 90 degrees into the formula, it will spit out the metric 0, -1, 1, 0, and from here you can actually derive also the change. So here you'll find out that this is 0x is here, so I did not put an x at the top. Then I have a minus y, I have a -1, so that's -1y, and at the bottom we have an x here at the bottom, and there's no y at the bottom there. So there's many cheeky little ways. There's so many options that are available for you. You have to just pick what you like and master it. All right, but the important thing here is to know how to get your rotation metric, because without the rotation metric you are going to be unable to find the position of the points. All right, and what you're seeing here on screen is just a case where I'm showing you how to derive the change. If you can't remember the change, you can move from the formula to the metric, from the metric to the change, or you can just simply study the change. Example, just thinking about it now, 90 degrees anti-clockwise rotation is in fact negative y x. Rotation of 180 degrees is negative x, negative y. Rotation of 270 degrees anti-clockwise, it is y, negative x. That works for me. What works for you? Let me know in the comments. Now that we have seen all of what has happened, then it is time to demonstrate here on the graph. Let us use a question then to see what this actually looks like. Before I load up some images on my screen, on my slides, and you've seen them for yourself, but we want to be able to apply this concept on our own. So now that we have seen how to determine the rotation metric, let us do some calculations and plotting. So given that the point F is 2, 1, the point G is 5, -1, and H is 3, 5, which forms a triangle that undergoes rotations about the origin 0, 0, rotation through 90, rotation through 180, and 270. The question is, show by calculation using matrices the coordinates of the image FGH under the rotations and draw each image on the graph below. All right, that's the question. Now let's go ahead and plot point F, point G, and point H. 2, 1, 5, -1, and 3, 5. So 2, 1, 2 to my right, 1 up, 5, -1, 1, 2, 3, 4, 5, -1, and then we have, of course, 3, 5. So that's 1, 2, 3, 1, 2, 3, 4, 5. And that's F, G, H. Connecting them, we're forming this shape here. Oops, it's a bit lean there, guys. So we have this triangular shape here, and we're going to be rotating this through 90, through 180, and through 270. So let's get to it then. Of course, if you want to go through the whole rigmarole of writing down the formula, getting to the metric, then doing the change, you can do that. For now, I think that we've went through thoroughly what the matrix are. So I'll know that R of, say here, the positions F, G, and H, I'm going to do all of them at once. So I'm going to do R, I'm going to rotate all the points at once. So the rotation metric of, say here, 2, 1, 5, -1, and 3, 5. Let's make sure that we have the points correct. So 2, 1, 5, -1, 3, 5, right? Once I rotate this through 90 degrees anti-clockwise, then what's going to happen is that the points are going to flip and the y is going to change. So 2, 1 is going to become negative 1, 2. 5, negative 1 will become 1, 5. And 3, 5 will become negative 5, 3. So notice that the 1 changed to negative, the negative 1 changed to positive, and the 5 changes to negative. However, the 2, the 5, and the 3 remains as 2, 5, and 3. And that's basically the change. Now, when the question says use matrices, what you're saying there is that you should actually use the matrix, say here 0. You should use the matrix, I think the matrix, if I remember correctly, for 90 degrees is in fact 0, negative 1, 1, 0. And you should multiply it by 2, 1, 5, negative 1, 3, 5, and by going row by column, and this is off the assumption that you know how to multiply matrices, then row by column will produce the same answer here: minus 1, 2, 1, 5, negative 5, 3. It will produce the same result once you go row by column, and we can check it. 0 times 2 is 0, plus negative 1 times 1 is negative 1. 0 times 5 is 0, plus negative 1 times negative 1 is 1. 0 times 3 is 0, plus negative 1 times 5 is negative 5. And 1 times 1 is 1, pardon me, 1 times 2 is 2, plus 0 times 1 is 0, 2 plus 0 is 2. 1 times 5 is 5, plus 0 times negative 1 is 0. So 5 plus 0 is 0. Again, 1 times 3 is 3, plus 0 times 5 is 0. 3 plus 0 is 3. So we know when they say use a matrix method or use matrices, they're looking at they're requiring you to write it down in this form. But if you know what the changes are going to be, then you don't have to go through all of that. All right, I do recommend though that you follow the instruction and you just write it down in a matrix form, because that's what they're requiring here. So then we can go ahead then and plot these points, and you're gonna see that the object lands somewhere over here. So minus 1, 2, so that's minus 1 to my left and 2 up. That's going to be my f prime. 1, 5, so that's 1 to my right and 5 up. That's all the way up here. That's my g prime. And my h prime is negative 5, 3. So that's 1, 2, 3, 4, 5, up 3, 1, 2, 3. That's my h prime. And by connecting this here, you'll see then that a rotation has occurred. Oops, I think that's way not straight. So let's just get into it here, guys. I think that my direction is here. Okay, I think I've got it, guys. Okay, beautiful. That's my rotation then of 90 degrees anti-clockwise. All right, we can then proceed then to do 180 degrees, say here, anti-clockwise. So we can go ahead then and just let me see if I have any space at the bottom. There's none, so I'm just going to use my space here. So make sure that you guys have this calculation written down. You can pause the video and just take out the information then. Let's go again then. I'm going to rotate then the object again, say here 2, 1. I'm going to rotate, say here 5, negative 1, and we're going to have, say here 3, 5. And so once I send that through 180 degrees, you will find then that the points are going to just change signs. So of course 2, 1 is going to become minus 2, minus 1. 5, negative 1 is going to become minus 5, positive 1. And 3, 5 is going to become minus 3, minus 5. Or if you write it down in a matrix form, then we know that it is minus 1, 0, 0, minus 1. Once you know your matrix, you're going to multiply it by the points 2, 1, 5, negative 1, 3, 5, and that will produce the result as we have it up here. Minus 2, minus 1, minus 5, 1, minus 3, minus 5. And we have already went through the whole fact that row by column will in fact produce this result. So we can go ahead then and plot minus 2, minus 1. So that's minus 2 here, minus 1 down. That's my position then. Minus 5 up 1. So that's minus 5 up 1. So this is my F double prime. This is my G double prime. And this is my H double prime, negative 5, 3, negative 5. So that's negative 3, 1, 2, 3, negative 5. 1, 2, okay, 1, 2, 3, 1, 2, 3, 4, 5. Okay, and that's my H double prime. And so when I connect these, then you will find here that is my rotation of 180 degrees from the white triangle. And then of course, same procedure here, nothing will change. I'm going to go ahead then and I'm going to do a calculation of 270 degrees anti-clockwise. So we're going to have the rotation of, whoops, it's too small. So we're going to have the rotation of the point 2, 1, 5, negative 1, and 3, 5. Sending that through 270 degrees will produce the result of a flip and the X changes. So the 2 is going to go down and change. The 1 is going to come up and remain. The 5 is going to go down and change. The negative 1 is going to go up and remain. And the 3 is going to come down and change. The 5 is going to come up and remain. Of course, you can do the same thing here. The matrix is going to be 0, 1, minus 1, 0. And therefore then multiply by 2, 1, 5, negative 1, 3, 5. Which will then produce the same result as 1, negative 2, negative 1, negative 5, and 5, negative 3. So again, if you know about matrices row by column, you will realize that it produces the same result here. And so of course you can go ahead then and plot 1, negative 2. So that's 1, say here, and down 2. So I'm going to be at this position here, 1, negative 2. Then I have negative 1, 5. Sorry, negative 1, negative 5. So that's negative 1 here. 1, 2, 3, 4, pardon me. So that's negative 1 here. Boom. 1, 2, 3, 4, 5. So that's my F triple prime. That's my G triple prime. And now my H triple prime is going to be 5, negative 3. So that's going to be 5, negative 3. So that's 1, 2, 3, 4, 5, 1, 2, 3. Right here. That's my H triple prime. And when I connect this, say here to this, and here, I get a beautiful triangle rotated of 270 degrees, say here, anti-clockwise. Alright? And that's pretty much really what entails rotation in the surface level information. Once you know your rotation matrix, you simply just rotate your matrix. Sorry, you use your rotation matrix to multiply the coordinates of the object that you're rotating. It's not always going to be the original object. So you have to read the question. If they say to you rotate the object or rotate the image that you just reflected, it really depends. You really have to read the questions. Of course, I'm going to have a bunch of questions, worksheets, transformation worksheets from past paper questions coming up on the channel. So if you're in preparation mode for exams at the point of watching this video, you definitely want to check out my tutorial videos on those, on my playlists. All right, transformation, practice worksheets. All right, and how you can apply this concept to various areas of transformation. All right, and so of course then we're going to be looking in part 2 at how to calculate the center of rotation given the object point and a translation. We're going to look at how to construct the center of rotation, and we're going to also look at the properties of rotation. So there's many things left to be discussed in rotation. Also, we're going to be looking at how to rotate an object from a point that is not on the origin. So definitely guys, you want to hit that subscribe button below, and you want to turn on your post notification bell to be notified whenever I release that video. Alright, or if you've already been subscribed, you can check on my transformation playlist that I will pin a link in the comments or in the description, and you can check out all the other valuable contents that are available, not only on rotation but on also enlargement, reflection and translation. So until next time guys, I want to thank you so much for staying tuned for a little bit under an hour. I hope that this was a rather unraveling session for you, and you found value and you got clarity. Alright, and if of course all those were achieved, be sure to hit the like button before you go. So I'll see you next time in another tutorial video. In part 2, we're going to be talking more in depth about rotation. Alright, until then, take care. Bye bye.